Good day everyone. Welcome to Teacher Julie channel. Hello everyone. We have our new lesson in Earth and Life Science, which is all about relative and absolute dating. This will be the first quarter topic and week 3. This lesson is under the milk-based. Before we proceed to our discussion, so let's have an activity called Find the Words. So all you have to do is to find the following words. Geologists determine the relative ages of rocks and other structure by examining their places during a sequence. If a layer of rock is offset by a fault, which may be break in the Earth's surface, you recognize that the layers had to be there before a fault could cut through them. So relative dating is used to arrange geological events and the rocks they leave behind in a sequence. The reading is called the stratigraphy. It is a layers of rock are called strata. There are 3 principles in determining the age order of a rock. The principle of superposition states that sedimentary rocks are normally laid down in order, one on the top of another. That in a sequence, the youngest is at the top. Another principle is the principle of horizontality. It states that most sedimentary rocks lay down in flat horizontal layers, although this can later tilt and fold. And the last principle is the principle of lateral continuity. It states that layer of sedimentary rock extends sideways in the same order. A later event, like a river cutting, may form a gap, but you can still connect the strata. A sequence of rock may be a record of past events. Most of the rock sequences are incomplete. Layers are missing. These gaps in rock sequences are unconformities. An unconformities is a gap in the rock record caused by the erosion or pause in deposition. There are 3 major kinds of unconformities. The nonconformity, horizontal layers of sedimentary rocks overlie older igneous or metamorphic rocks. When horizontal rocks layers are exposed and eroded, and new horizontal layers of rock are deposited on the eroded surface, it develops disconformity. An angular unconformity develops when new horizontal layers of rock form on top of older rock layers that are folded by compression. Absolute dating can be achieved using historical records and through the analysis of biological and geological patterns resulting from annual climatic variations. Since 1950, the physical sciences contributed a number of historical of absolute dating techniques that have a revolutionary effect on archaeology and geology. These techniques are based upon the measurement of radioactive processes. Geologists often need to know the age of the material that they find. They use absolute dating methods, sometimes called the numerical dating, to give rocks an actual date or date range in numbers of years. Geologists determine the absolute ages by using properties of the atoms that make up materials. Most absolute dates for rocks are obtained with radioactive minerals in rocks as geological clock. Different elements are used for dating because they have different decay rates. The process of breakdown is called the radioactive decay. For geologists, isotopes are important in all techniques for absolute dating. Hence, different elements are used for dating because of their unique decay rates. Isotopes are atoms with chemical elements having different forms. The half-life of an isotope is the time it takes for half of an atom in the isotope's decay. For example, the half-life of carbon-14 is 5,730, while the radioactive carbon dating measures radioactive isotopes in one's living organic material instead of rocks. So using the decay of carbon to nitrogen 14. Because of the fast decay rate of the carbon 14, it can only be used on material up to about 60 years. Most of the radiometric dating methods measure isotopes in some way. Most directly measure the number of isotopes in rocks using a mass of spectrometer.